Hello, I'm not in class today as you can tell, but I am on campus. So if you have questions about any of this, you can come see me later or you can ask me tomorrow. But first, in this video, I do want to go over your homework that you had on page 33 and 34. So on page 33, you guys have these numbered as 1, 2, and 3. 1, 2, 3. So on number 1, it says find an equation of the line containing the altitude from G to FH. So you had to see that if I create an altitude, not only does it go through G, but it also needs to be perpendicular to FH. And the equation of this line is going to be x equals 2. It goes through the x-axis at 2, and also every single pair of coordinates within that line is going to contain the coordinates of 2, comma, something, right? So that is the equation. Next, number 2 wants us to find the equation of the line containing the altitude from H to FG. So not only does it have to pass through H, but it needs to be perpendicular to FG, which means I first and foremost need the slope of FG. And if you look at the slope, you should have hopefully saw that it was up 1, right 1, up 1, right 1, up 1, right 1, etc., etc. And if that's true, then I know this has a slope of positive 1 over 1, which means the negative reciprocal perpendicular slope would be negative 1 over 1. On number 2, I had to use that slope to create an equation. Remember the point slope form? It's y minus a y value of a pair of coordinates equal to the slope, which we just said needed to be negative 1, times x minus the x values of a point on that line. Now, as far as using a point on the line, if I'm making a perpendicular bisector, if I follow that negative 1 slope from the only point I know, h, I can go up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. And when I do connect those points, I wind up with an altitude that not only passes through h, but also winds up perpendicular to FG, which means I do know for an absolute fact that the coordinates of h exist on this line that I just created. And h's coordinates are 4, 1. So when I go and substitute those values into my equation on number 2, I see that if h has an x value of 4, I'm going to subtract 4 from x. If h has a y value of 1, I'm going to subtract 1 from y, and I'm done with number 2. Number 3 wants us to find the system or solve the system of equations like we did in class to find the orthocenter. Right now, I actually already know my orthocenter. It's right here. It is located at 2, 3. Now, if I didn't automatically see that, or if it wasn't a nice, clear, concise location, I could solve the system of equations by figuring out what would make them both equal to each other. Which means if x is 2 at that orthocenter, what would y wind up having to be? So I could plug 2 in for x and solve my equation. I would find that inside of these parentheses, 2 minus 4 gives me negative 2. I have negative 2 times negative 1 to get positive 2. And then when I add 1 to both sides, because of that minus 1, I wind up with 3. So y is 3 when x is 2, and that's my answer on number 3. Again, if you have questions on that, come see me later or tomorrow. Number 5 was the same kind of idea, but I'm going to go through it quickly. I look for any horizontal or vertical lines that I could easily draw a segment perpendicular to, and I see that WX is perfectly horizontal. So I know that I want a segment perpendicular to WX and also passing through the opposite vertex Y. So I know one of my altitudes is right here. Now I want to draw in a second altitude, and I could pick either one of the other sides. Personally, I'm just going to choose YX. So if I look at YX, I know I want to draw a segment that's perpendicular to that one. I also want it to pass through the opposite vertex, which is W. So in order to do this, I need to determine the slope of xy. Right now, the slope of xy is up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. So if my slope is positive 1 over 1, I know my perpendicular slope is going to be negative 1 over 1, or just 1. So I create my equations, or actually let's draw this in first. So from W, I'll follow the slope of negative 1. Down 1, right 1, down 1, right 1, down 1, right 1, and I realize I'm actually following along the triangle. This is perpendicular to side xy, and it's passing through opposite vertex W. And if I pay close attention, I actually see that the two altitudes cross paths. They cross paths right here at 4, 2. And if I think about this, that actually makes a lot of sense, because if I look closely, this is a right triangle. And what we learned about orthocenter is that if it's on a right triangle, it's going to be at the vertex of the right angle of that triangle. Last, number 7. If I were to create a coordinate plane for myself and just kind of sketch out what's happening here, I actually figure out what they're asking. So if I have A at 0, 6, so 1, 2, 3, 4, 5, 6, and I have B at 8, 6, 1, 2, 3, 4, 5, 6, 7, 8, and then I go up to 6. This is A, this is B, and C is 1, 2, 3, 4, 5, 0. In this triangle, I can now start to focus on creating my median CD. My median goes from vertex to the midpoint of the opposite side. And if A is at 0 on the x-axis and B is at 8 on the x-axis, then I know my midpoint is at 4 on the x-axis. So this would be my median, bisecting that side, right? Because that's at the midpoint. So this is D. And then my altitude is, so my altitude CE is going to go from the opposite vertex, and it's going to go perpendicular to the opposite side. So I'm going to have a vertical line go straight through C. And that gives me point E. So while D's location wound up being at 4, 6, E's location wound up at 5, 6, which means they are 1 unit apart from each other. Again, if you have any questions on the homework, let me know.